Hi children, welcome back to Max class. Hope you are all again busy with regular 3 slots and enjoying your learning. And we are also really happy that we are again back with classes. Okay children, today we are going to continue with the chapter linear equation in one variable, and it is part 3. Okay children, as usual, let us have a thought in video mode today. Are you all ready to see this video? Here is an eagle. This is a story of an eagle. Actually, it can live up to 70 years, but not at a stretch. To reach this age, the eagle must make a tough decision, and it is not an easy decision. And it has to take this decision in its 40th year, when its long talons become weak, its beaks also becomes weak, and they cannot catch and eat prey, and their feathers will also become very thick and heavy, and they cannot fly easily and fastly. So in such a tough situation, it has to take a decision. Tough decision and not an easy decision. That is either to die or to change. So it undergoes the process of change by going to the top of a hill and sits in its nest. Then there it knocks its beaks and breaks its beak. And we do feel that pain when we cut our nails very close to flesh, isn't it? And this eagle takes the chance of breaking its beak. Then it waits till it gets a new beak. Till then, it has to be without food. Imagine how hard and how difficult is the phase of change for an eagle. And it is worth waiting for such thing. And let us continue this video. And once the new beak has grown, it plucks its talons in the sense nails that it uses to catch its prey. Then at last, it changes its feathers also. It plucks its own feathers, old age feathers, and new one starts growing. And finally change has happened. The change that worth sustaining the pain. The pain was worth enough because it's going to live next 30 more years happily and a new birth. Let us get into today's session. Okay, in last class we started with variables, constants and operation or the basic components for our maths language. Hope you remember. When one is thorough with that language, they can play wonders. They can do wonders in that language. Similarly, make your mindset that you should be strong in this chapter. If you are thorough, if you are able to handle this variables, constants and operation under an equation, then you can do all other chapters easily. Okay children, and now along with this, with the combination of these variables, constant and operation, we got expressions. Literary expressions were converted into mathematical language and it is called as expression. When this expressions has an equal to sign or when a condition is applied over that variable, we get an equation. And here are few expressions. 5x is an expression. That is 5 is multiplied by a number. Then 2x minus 3 is an expression. 3x plus y is another expression. 2xy plus 5 is another expression. xyz is plus x plus y plus z. This very big expression. And x squared, x power 2 plus 1 is also an expression. Y plus y power 2 is also an expression. Are you able to see the difference in their expressions? We have varieties of expressions here. We do have varieties of expressions in our face like happy, sorrow, cry, many expressions. Here in Maths 2 we have different types of expressions, but as a baby it knows only to cry and laugh. Only two things. Baby. And we are all baby enough in learning this new language. So we are going to have only two expressions. One is linear expression and another one is non-linear expression. I have sorted out all these expressions into two kinds. One is linear and another one is non-linear expressions. In linear expressions, see the difference between these two. Can you find the difference? Yes. Here we have raised to the power 2. Raised to the power 2. And many things comes in product. But here the power is always 1 for the variable. Yes, children, linear expressions are expressions where the powers of the variable are not greater than 1. And if it is greater than 1, it comes under non-linear expression. This non-linear expression can be subdivided into many expressions. Like sad expression, like that crying expressions have many different expressions. Even that smile expression of a baby has different criteria when they grow up. Likewise, now as per linear expression, we are going to learn only linear equation with only one variable. Only one variable, either x or y or z or m or n. But together we will not learn. See here, we have two variables in this expression, x and y. We are not going to deal with such equations. We are going to deal with equation only where we have only one variable and their power is also 1 and not greater than 1. Hope you are clear with linear expressions and non-linear expression. And in previous classes, we discussed linear equations in one variable and solved few examples. Hope you remember all these examples. If not, play back that video and understand it. Is it clear? This we solved using which rule? Yes, we used transposing rule. Once we solve that equation, we get a solution for an equation. What is solution of an equation? It is the value that we get as an answer, single value. For which we do get a single value? For a variable, x is equal to, m is equal to, p is equal to, we get some value for a variable. That is the value of the variable that satisfies the linear equation. We check, no? In checking process, we check whether LHS is equal to RHS. That means that it satisfies the linear equation. So that answer, that value, single value is called the solution of an equation. Hope it is clear, my dear children. And now it's time for you to think. Linear equation in two variable. Any idea? Can you give me some examples for linear equations in two variable? Just now I showed you. Yes, you are right, my dear children. Here I have stated 2x plus 3y is equal to 12. You can say x plus y is equal to 3. Or you can say m plus n is equal to 15. Or m is equal to 12 minus n. Anything, but that equation will have two variables. And it is a linear. Linear in the sense, the power of that variable should be equal to 1. The power that we write as a superscript, that number should be 1. Even if there is no number, it means it is one time, not many times. Okay. Is there any relationship between linear graph and linear equation? Did it strike your mind? Linear graph we learnt as a third chapter. Hope you remember line graph, linear graph. Is there any relationship between linear graph and this linear equation? Do you think? Yes, children, we do have a relation. See here, this is the graph of this equation. You will learn how to draw a linear graph for the linear equation in higher classes. But you should know that these two concepts are related and they are not two different concepts. They all will come and merge at the same point. Okay. So linear graph and linear equations are graph is the diagrammatical representation of the linear equation. Okay, children. And before getting into word problems like story problems where we use these linear equations in our day-to-day life, today we are going to see the applications of these linear equations. Here are a few tips that will help you in reading and analyzing that word problems. If you come across the word sum, add, together, moves up, more than, all these words will give us an idea about addition. And whereas difference, less than, subtract, and what other things, moves down, okay, younger, all these words relates to the operation subtraction. These many times, of, this of is a preposition. Depending upon the position where it is in that sentence, it makes a difference. Some places we consider this of as multiplication. You should know to differentiate the position where it is and what it means. And divided by denotes the operation division. Hope you know that. And double, you will come across word double, triple. Okay, it means 2 into, not 2x, 2 into. Triple means 3 times, 3 into. These words you will come across in word problems. And half, 1 by 2. What is 1/5? 1 by 5. What is 2/3? 2 by 5. Everything they will write it in literary form. And we should change it into mathematical language. And let's start with an example now. Here, what should be added to twice the rational number minus 7 by 3 to get 3 by 7? I have highlighted the words add, keywords that I have shown in previous slide. These will give us clue and help us in making the equation. What should be added? So I am going to add something. Okay, add means we have to have at least 2 things to be added or more than 2 things. What I am going to add? Twice. Twice in the sense 2 into. Twice the rational number minus 7 by 3. What should be added to? Twice the rational number minus 7 by 3 to get 3 by 7. Twice this rational number. 2 times minus 7 by 3. Instead of multiplying and giving directly 2 sums of 14, 14 by 3, they are rounding up as to make us confused. So you should be careful. What should be? I don't know what is that what. So I will have that what to be x. Okay, I will have it to be x. Okay, this x is added to twice that minus 7 by 3. Is it clear? X plus 2 times minus 7 by 3 to get in the sense equal to. Is GIVS gives, these words will state it is about equal to. So our equation will be, let the number be x, that what we have to find, x plus added to twice minus 7 by 3. With the help of that statement itself, you should be able to find the equation. Once the equation is ready, you should know. It is very simple to simplify. Minus 14 by 3 is equal to 3 by 7. This has to transpose to this side. Minus 14 by 3 will come as plus 14 by 3. Then you know it is about cross multiplication like this. 3 3s are 9 and 7 14s are 98. If I add the numerators, I get 107 by 21. Hope we got the answer. And